Hello students, this is Mrs. Crawford. This lesson is going over the block day lesson that we got. It's the same notes page that you received on Monday, just the back side of it now. I do want to really quick review the multiplying section that we discussed. You were supposed to do these 3 problems at kind of the bottom of that top section. So I don't want to go over them really quickly just to remind you about multiplying because you will use that a little bit today. First of all, make sure you know which one the coefficient is. That's usually the number in front. So those ones right there would be the coefficients. You don't treat them any differently than normal. So -4 times 3 is still going to be just -12, just like we normally would. Now when we get to the exponents, that's when it's a little bit different. Remember we talked about with multiplying exponents, you're really adding up the numbers because c to the 2nd power really means that. C to the 4th power really means that. So if I was to count up all of those, it's not c to the 8th, it's not 2 times 4, it's actually only 6 of them. So it is c to the 6th power. Same thing with your second one. Start with your coefficients first. Those are the big numbers in front. 8 times 3 is 24, just like usual. And then you have r to the 3rd times r to the 8th. That means I have 11 r's altogether. So it's r to the 11th power. Last one, again, make sure you started with your coefficients. 6 times 7 is 42. And this time we've got 2 different sets of base variables, so it's going to be a little bit trickier this time, but not too complicated. We've got f to the 2nd power, and then this is really f to the 1st power. Remember, you add up the exponents, so this is f to the 3rd power. Make sure you pay attention to the fact that this is a 1. I know there wasn't anything written there originally, but if it's by itself, that's just a 1. Then you also have g to the 4th and g squared, which means I'm going to have g to the something. Well, 4 plus 2 is 6, and these have to stay separate. You can only combine variables if they have the same base. So now we're going to move on to the dividing section. First of all, though, I want to give you a couple little things about where exponents are used. One of them is showing population increase. If any of you guys have really, really big families at your reunions, you might have grandma, grandpa who had 4 kids, and each of those 4 kids, which would be like your mom and dad, aunts and uncles, they each had 3 kids, and before you know it, you have this giant packed house of people who just came from 2 people. That's what population increase is, and it's all based on what we call exponential growth. Each time you have a person having a kid, those kids in turn have more, so it grows and grows and grows exponentially. So here's the section on dividing with exponents. When you're dividing, you're really going to be subtracting the numbers, and I'll show you why in just a second. Make sure when you divide the coefficients that you treat them just like normal, don't do anything different, and then you also combine exponents that have the same base. So in other words, x's with x's, y's with y's, don't mix and match, just put them next to each other. So the reason why we subtract is this. F to the 6th power really means f times itself 6 times. So it kind of looks like this. It's being divided by f to the 3rd power, which means f written out 3 times. Now what happens when you have something divided by itself? Well, 1 divided by 1 is 1. 5 divided by 5 is still 1. 100 divided by 100 is still 1. So that means that f divided by f should equal 1 as well. It's the same kind of idea. Well, if I have f divided by f, and that really is just the number 1, if I change this whole thing to a number 1, that's just going to make it the same as it already is. I mean, f times 1 isn't going to change it. It's still going to be f. So really, I can just get rid of it. I can eliminate it. Same thing with these 2 groups. Now, I don't have any more on the bottom to get rid of, so I have 3 of them remaining on the top, which is why the answer is f to the 3rd power. Instead of doing 6 divided by 3 and getting 2, it's really 6 minus 3, and that's how I get f to the 3rd power. Over here, we've got some coefficients to deal with first. We have 6 divided by 2. And you can treat that just like normal. You can either just divide it straight and get 3, or you can kind of treat it like a fraction to reduce. If I divide the top and the bottom by 2, I get 3 over 1, which really is the same thing as 3. So I'm going to put 3 over 1 for right now in case I have anything left over on the bottom. If I don't, I can get rid of it later. And then I've got w to the 12th divided by w to the 2nd power. Now remember, when you're dividing, you're actually subtracting the numbers. So 12 minus 2 is 10. And you put the answer wherever there are more of that exponent in the fraction. So there's w to the 12th on top, there's w to the 2nd on the bottom. Well, 12 is obviously more than 2, so the remaining numbers have to go in the numerator on top. Since nothing got left in the denominator, I can get rid of that fraction and just leave it as 3w to the 10th power. This last one you really got to be careful with, especially because of these coefficients out front. And I'm actually going to move them separate over here. So negative 8 divided by 16, that does not equal negative 2. Please be careful about that. Don't just write that. You have to look at what you can divide them both by. Well, 8 and 16, I can divide them both by 8. That would be the biggest common factor. If I do that, negative 8 divided by 8 is negative 1. 16 divided by 8 is 2. So there's my simplified fraction, negative 1 on the top, 2 on the bottom. You do need to make sure to simplify those coefficients. We've now got s to the 3rd, and this is really s to the 1st power. So check those. If I subtract their exponents, 3 minus 1 is 2. There's more in the top, so my answer, s squared, or s to the 2nd power, has to go up there. Now you can also take a look at the h's as well. Or you should take a look at the h's. There's more on top, so I know my answer has to go there. 7 minus 4 is 3. So my final answer is negative 1 over 2, s squared, h squared, or h to the 3rd power. So go ahead and try these 3 problems. You need to pause here and try them on your own. You could just cheat and fast forward and get the answer, but you're really not helping yourself, so at least practice it. Make sure there aren't any mistakes that are easy that you're making. So pause here. All right, here's what your answers should be. There's a 1 right there, subtract it, you get n to the 6th power. You got coefficients in front here. 6 and 16 can both be divided by 2, so I get 3 over 8. X to the 14th, x to the 7th. 14 minus 7 is x to the 7th, and it's got to go on the top because there's more of them there. The last one, 12 and 9, can both be divided by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. And then I got to take these groups one at a time. P to the 6th power over p to the 2nd power. It's going to end up on the top because there's more of them there. 6 minus 2 is 4. I've got y to the 5th on top, y to the 5th on bottom. If I was to write that whole thing out, it would look like this. And because there's the same amount top and bottom, they all cancel out, which means this is gone. It really equals the number 1, but if I write that there, it's kind of unimportant. 4p to the 4th times 1 is really just 4p to the 4th, so I don't need the 1 there. So there's your answers for that first group. All right, so before we move on to the last section, one of the other big places where exponents are used is showing sales. Now, I'm sure this looks pretty familiar to you. A lot of you have iPhones. I myself have an iPhone too. They're pretty popular. 2008, we started off with a pretty small amount, about 1.7 million it looks like, and progressively through the next 4 years alone, we jumped up to 35 million being sold, and I'm sure today in 2017 we have way more sold as well. So this is actually what we call exponential growth, this curve line. is what you get when you use exponents. Anytime you have exponents, you get a curve graph, either kind of shallow or super, super steep. And it's used a lot in business to kind of calculate and see where do they think their next one might be. So if I was to take a guess and I drew this, it would probably end up somewhere in maybe like the 45 to 50 million amount if this graph keeps progressing as it should. All right, last section, we're talking about combinations for this one. That is when you're using multiplying and dividing. First thing we want to do is do the multiplying section. So we do top and bottom. So the numerator, we take care of everything there. That's the top of the fraction. We do all the multiplying we can on the denominator or the bottom of the fraction. And then we do top to bottom. We do dividing after that. So go ahead and fill in those blanks. All right, so with this one, I'm actually going to cover up part of my problem, just that top part. So first of all, let's rewrite the coefficient. We've got a 4 here. Nothing is being multiplied by the 4, so I'm just going to rewrite it over there. We've got x to the 6th times x to the 1st really is there. Think back to what we talked about at the beginning. When you multiply exponents, you're really going to add up their numbers. So it's 4x to the 7th power now. And nothing is going to happen with the y to the 8th. Nothing's getting combined on that top part. So we're just going to rewrite it right there. Okay, so that's the numerator. We've combined everything we possibly can there. Now we've got the denominator. Again, start with your coefficient. You can't do anything with the 6, so just rewrite it. We've got x to the 4th, but there's no other x's here, so I'm going to have to keep that the same. We've got y to the 1st times y to the 2nd. Remember, we're multiplying, so we're really going to add 1 and 2 and get 3. Come on, delete. This thing's being very persnickety right now. All right, so now we're going to put the two halves together and do some dividing. So make sure you're switching kind of steps in your brain. We did all the multiplying. Now we're going to work on dividing. So first of all, 4 over 6. I can simplify that. What could I divide 4 and 6 by? Well, they can both be divided by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So there's the simplified fraction. And then I got to look at my exponents. I have x to the 7th divided by x to the 4th. I'm going to keep the x in the top part because there's more of them there. So the remainder has to go there. 7 minus 4 leaves me with 3. And then I also have y to the 8th, y to the 3rd. Again, the y has to go on the top because the remainder, there's more of them. 8 minus 3 is 5. So there's my final answer. 2x to the 3rd, y to the 5th, all over 3. What I'd like you guys to do now is pause real quick and try this guy. About the same level of difficulty as the last one. Remember, do the numerator first, then do the denominator, and then unpause, and I will show you how to do this problem. Alrighty, top part, 10 stays the same. M to the 3rd times m to the 1st is m to the 4th. Because I'm adding up the numbers. N to the 7th stays the same. On the bottom, the 5 is just going to stay by itself. We have n to the 1st, that's not just attached to the 5, it's just multiplied, so I can move it around. Times n to the 3rd, add them up, I get n to the 4th. And then I've got this m squared here. Simplify it out, 10 and 5 can both be divided by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. I'm going to keep the 1 there for now. Might be able to eliminate it later. Then I've got m to the 4th divided by m squared. When I subtract, that leaves me with m squared on the top. I've also got n to the 7th and n to the 4th. Again, bigger number is on top, so n to the 3rd is my remainder. I don't really need the 1 on the bottom, so I can get rid of it. And then there's my final answer. Homework is that separate piece of paper.